Okay, looking at first thing, we're going to a little bit different. We did a lot of independent practice first today, which is we needed to since yesterday we got so crammed with time. Can you guys stop writing for a sec? Stop. I want to go over the announcements so we're all on the same page. Okay, so you might have noticed this week I'm trying to figure out how to support you better, but also make it manageable for me. So this weekend what I did was I sent a missing assignment message that went out to your parents and you. You guys get those. So if you're missing work, you would know. So this is what I decided I'm going to do. When I send those out, I'm going to give you 1 week to turn that stuff in. Because what happened this past weekend, I realized, I was like, boy, it wasn't working for me. Because I had like a step. And that is awesome that you guys passed in missing work. It's just that some of it was like 3 weeks old. I even got a few pages back from like the beginning of the quarter, which was like beginning of October, which is hard for me because I don't remember that warm-up. Like it's not in my mind, and I can't give you good feedback on whether or not it's right, because I'm like, wait a minute, was that the right day? So it just made it really difficult. And so I figured what would be best for you guys if I did my work, which was to tell you sooner if you're missing work, and then give you an appropriate amount of time to get that back to me. So basically this week, I sent that on Friday. I'll take work up to Thursday. And then we kind of start over fresh. Okay? So that's kind of how we're going to do it. And I think what's better about it too is that you're not doing stuff so old that it's not helping you now, right? We want to, and that was the other thing. I was like, man, this is so old, like, it's not really helping you for this unit. So anyway, quizzes and retakes will happen tomorrow during lunch. If you're happy with your quiz grade, obviously you don't need to do a retake. If you're not happy with your quiz grade, now I would imagine some of you were like, I could do better. You just can't show up to take it again. You need to do this. There weren't that many questions, so it's not going to take you long to do this. But if you got, a 20 out of 30 or an 18 out of 30 or 16 out of 30, this might be a good option because I believe that you could do better. I'm not going to make everyone retake that quiz like a unit test. Hey, but that is an option for you if you want to do that. If you got a 22 out of 30, you can still retake it because I do believe you can do better. So that's going to happen tomorrow at lunch if you want to do that. Homework. Okay. Scale factor. Talk to your partner what you think a scale factor is. Go.
Scale factor is like
deja vu for you, Max.
I have an original shape. Scale factor is like how many times the original shape went to like the new shape. So if it was this,
scale factor.
This is the original shape, and the scale factor for here would be 2 because it's 2 here, 2 here. The sides went like 2 times bigger, right?
Right.
I still got the picture.
I
can show you it right now.
It's Photoshop picture. It's Photoshop.
Fucking Photoshop.
Okay. Scale factor. So the scale factor is how many times bigger? Yeah. Just wait. Or smaller, corresponding side is compared to the other corresponding side. So, yes, scale factor works with shapes because all sides are increased. We call that the constant of proportionality, when the whole shape is increased. There's a scale factor, and we call those figures similar figures, just like we have in the back. But a scale factor can work with just the side. Okay? And we have to compare one corresponding side to the other corresponding side. So, if you know the scale factor one way, if I know that from a small figure to a bigger figure it's a scale factor of 2, I know the other way is the reciprocal of 2. Well, we know that 2 is 2 over 1, so the other way is 1 over 2, the reciprocal. I flip that fraction. So if I had a scale factor going one way at 3 halves, the other way would be 2/3, just the reciprocal. So we're looking at identifying the scale factor, and then we're looking at, and I put draw similar figures. It's more about us identifying the scale factor through similar figures, and then yes, we're going to be able to draw them. So that's what we're working on today. Tell your partner what a similar figure is, just to make sure that you're good here. Go.
Similar figure is a figure with corresponding
angles, so like
no, similar figure is
All right, Charles, listen, you guys.
corresponding size, corresponding
Similar figure, same shape, corresponding angles. That means the angles are exactly the same from one figure to the other. Exactly. And then corresponding sides. The corresponding sides have either increased or decreased by that scale factor. So we know similar figures have a scale factor. We're going to talk about your independent practice today. We're going to go over B, and it's going to take a little bit of time, so I want to make sure we have no misconceptions here. So please get your book out to B. Okay, so B. So what page is that on? So the people at home, it's on page 54. Okay. So B's on 54. We're going to look at B1, B2, B3. Now these are foundational to this whole unit. So please, if you have questions, and first hour was, or third hour, they were so good. Because I realized, well, they realized when I said, like, this is fun, they, all of a sudden hands started to go off and people started to ask questions. Because if you don't get this part, man, you're going to really miss out on a big piece of this unit. It's going to be hard. So we have sketches from question A. And so the first question is, what is the scale factor from each original triangle to each larger triangle? Now remember, we're making rectangles, so there is a scale factor. Talk to your partner about what that scale factor is and how you figured that out. Go.
Okay, so the scale factor is 2 because there's 2 on the dial. And check that. There's 1 here, and there's 1 here, and there's 2 here, 2 here, so that's the scale factor is 2.
Okay, so if here I have triangle ABC, this would be considered my original. Okay, Cam? Now I have triangle DEF. If I go to scale factor, it talks about how many times bigger or smaller corresponding side is compared to the other corresponding side. So step 1, Ben. Step 1 is, if I am comparing side length AB, what is the corresponding side for DEF? Ben. ED. This side corresponds to that side. So, and it tells me how many times bigger is this side to this side. So I know my scale factor right now is going to go this way, and because I'm going from a smaller to a bigger, what do I know about the scale factor? Cam, what do I know about my scale factor if I'm going from a smaller to a bigger? Try to be more specific.
8/2.
Yes, but it's going to be greater than what number for sure?
1.
Yeah, it's going to be greater than 1. And so here, if I have 1 there and I look, now I have 2. So I know I have a scale factor of 2 going this way. Tell your partner what the reciprocal of that, so we know the scale factor going the other way. Go.
1/2.
So if the scale factor is 2 going one way, another way to write that is 2/1.
Oh.
Lulu's like, oh, that's how you get 1/2. So yeah, that's 2. and I can write 2 over 1, which is still 2. I take the reciprocal of it, that's why it turns into 1/2. So, kind of starting off a little basic, but we figured out the scale factor, so let's go down to number 2 now. How does the perimeter of the larger triangle compare to the perimeter of the original triangle? Now you notice, now I'm not going from small to big like I did in the beginning. I'm going from big to
Small.
That's a different question. Talk to your partner.
I said
Yeah, someone's like, oh, I did that the wrong way.
Is 2 times as large as the original, but I shouldn't say the original.
Wait, is this the one we're working on right now? This one?
Yeah.
And am I meant to turn all of these shapes into reptiles, the big reptiles? Like, turn all of the small, medium reptiles into different reptiles?
Okay. So Riley, perimeter. We know something about perimeter, right? What does perimeter correlate exactly with?
The scale factor.
The scale factor. So we know that the scale factor and perimeter, they work together. And the reason why is scale factor changes side lengths. And so perimeter, that is what perimeter is a combination of all the side lengths. So if I said scale factor here, if I make that twice as big, I make that twice as big, and I make that twice as big. So it basically corresponds directly to perimeter corresponds exactly with scale factor. So, but now I'm going this way, and that's why I drew the reciprocal. So if I told you the perimeter here was 18. Oh no, wrong way, right? If I told you the perimeter here was 18, it's that plus that plus that. That DEF, triangle DEF, equals 18 inches. What is the perimeter of ABC? Axel.
9.
And you did that by taking the scale factor of 1/2, because I'm going from the big one to the small, and I'm multiplying it by my original perimeter, right? That's my original perimeter, and now I'm going to get a new perimeter of 9 inches. Questions about that? You guys feel like, okay, I get that. You've been hauling too many boxes, huh? Tired.
You've probably been playing Call of Duty.
You know what? You look probably been playing Call of Duty, not hauling boxes.
Yeah.
That would be rude. If I heard from your parents you were playing video games while they're moving, I would be upset. No way.
But you
No.
just got Call of Duty for it.
All right. So you guys feel good about 1 and 2? Any questions about 1 and 2? Lou?
I'm just.
So this is, let me see if I can help out with your question. This is my scale factor. This is my original perimeter, okay, my OP, and then I'm going to get a new perimeter. That's how I solve every question. So how about this? Let's say I'm going to change this rectangle just to see. Let's see how well we know this and how well we can use this. Oh my goodness. This algorithm. Okay? So we're going to use this algorithm. Here we go. I'm going to tell you that the perimeter of DEF is 42 inches, but the scale factor, now I'm going to challenge you, from ABC is 4.
Wait, could you repeat that?
Okay, I'm telling you the scale factor from ABC to DEF is 4. I'm telling you that DEF, this perimeter, is 42. So my question is this. What is the perimeter of ABC? Go, talk to your partner.
So
Yeah, make sure to work with that. They're on.
That'd be 10. Dude. Would that be 10?
21. Thank you.
Or wait, no, 10 and a half.
10 and a half. Yep, that's the answer.
Dude.
Warren G, how we doing? This is all pretty new to you.
I know it.
You got it? You got it? Okay. All right. So, hey, come back. All right. So, I kind of left one piece out. What was the piece I left out?
The scale factor going the other way?
Yeah, scale factor going the other way. So, if I know it's 4 going this way,
It's a 4.
David, what does it going the other way?
1/4.
1/4. So now I take the 1/4, bring it down here, put it into my algorithm, scale factor of 1/4 times my original perimeter of 42, and I'm going to get a new perimeter of 10.5.
Oh, man.
Okay,
so
you said 11, so you did that in your head, though. That's good. That's not bad math.
So you switch it going the other way?
I don't switch it. I take the reciprocal. That's the important word. Not switch. Please don't use switch. Don't do switch. It's the reciprocal, right? A reciprocal is where I take a fraction and I flip it. So does that make sense?
Yes.
What's great about that, guys, if you figure out the scale factor one way, it's like, boom, the other way. Piece of cake. You just got to have it right going one way. And then it's easy to do the other way. All right, last one. This is harder. I got 2. We're going to do 2 on this. How is the area of the larger compared? And remember, it's larger to original.
I have no idea what
All right, go for it.
I don't even know what
Cross two partners.
I said
I'm
the
doing
original
on
perimeter
what?
is 2 times as small as
On what? I don't even know what one we're doing.
Or do you
So I think, Max, what
I shouldn't.
it could be. Now you made some good ones.
No, I just don't
These
know.
are these are hard.
I actually.
What about this one? Use these.
I know, use them for what? I don't even know what we're doing. Like I actually don't know what.
Okay. Just be patient. Can you help them maybe get some understanding?
It's not that I don't understand. It's that I don't like. I
Okay.
don't know what the like. I don't know.
You don't know what problem we're doing, that kind of thing.
Yeah.
I got you, Max.
When you have the big triangle, what do you do to get
We're just
All right. So I'm going to use this one.
2 times
Like.
as the original.
So if I know going from here to here is a scale factor of 4, going back is 1/4. How much smaller in area is this? And how do I figure it out? In area, not perimeter. In area. Maya?
well, you take the scale factor and you square it.
So I know that if I know my scale factor going the right way, I can take it. Here it's going this way, 1/4, and I would square 1/4, which means that equals 1/4 times 1/4, which equals 1/16.
16.
So this is 1/16 the size of that. Yeah? So if I told you, what if I told you this then? This is, does that work? Yeah. That's 64. What's the original? Go, talk to your partner.
Okay, so 64 divided by 1/4 times 1/4.
Wait.
Area, we do C, 3.
C3. How is
Good
it
question.
the area of what triangle?
So I'm trying to figure the area of this one. So I know this one's 64.
16.
What one is that? Is that the first reptile we made, and then I have no idea what you're asking. I'm sorry.
I might have lost you when I switched gears from
No, it's
the last one
no,
to this one.
It's because I got in late, so I don't know what we're doing at all.
Okay.
The lesson plan.
All right. So I'm going to go back to an algorithm here. I'm going to show you an algorithm. So I know I can take my scale factor, this is my area algorithm, my scale factor squared, and I can multiply that by my original area, and that's going to give me my new area. My new area. So, do I know the original area?
Yeah.
64. Do I know the scale factor going from the original area to the new?
Yes.
Yes, 1/4. We already said that 1/4 is 1/16 if I square it. Right? 1/4 squared would be 1/16. So that's going to equal 64 over 16. Maya?
4.
So that 4. What does that 4 mean? Claire?
The 4 can, dang it, lost it.
Taylor, what does that 4 mean?
It's the area of the new.
Yeah, this is this area here. So if I know DEF has a scale factor of 1/4 going this way, and I know the area of this, I know the area of that. It would be this times the scale factor squared, and that gives me my new area. We're good? I know. It's okay. It's okay. I'm going to do one more. Okay? But this one, I'm going to switch it.
Let's give it a double triangle. Be gone.
We're going to say that the scale factor is 3,
Of what
and it's
kind?
1/3 going the other way. So now, I know the area of this, and it is 5. So now, if I know the area is 5 here, what is the area of the big rectangle? Talk to your partner, not about just the answer, but how you're getting it, okay? Go. In Orlando, work with it.
No, but remember the area is 4 times larger than the new one. What's the area of the new one?
No, he changed it to
The scale factor doesn't have anything to do. The scale factor I don't think has anything to do with the area.
Boom!
No,
Jackie!
area.
Woo! Man! There's smoke coming out of your brain. Smoke coming out of your
No,
brain.
so 5
Right.
plus 1.
that would be 45 then, right?
So I was listening to Jackie. Jackie was saying, "Hey, I'm going to use this algorithm, and I'm going to put scale factor algorithms up. There'll be a poster for it." So here she said, "Hey, I've got the scale factor. I know it's going from the original to new. This is what I'm trying to figure out. So that's my original. So that's 5." She says my scale factor is 3. I know this is 3 times bigger than that. So she says scale factor squared, 3 times 3 is 9. So I'm just going to do 3 times 3. That equals, hold on, let's do this. That's 9. So all I'm doing is plugging. Scale factor of 3, that goes in there. Old area, that's 5, or original, sorry. So now, this equals 9 times 5, which equals
45.
Now, we're not done. I love it that a lot of you got the right answer. Some of us are still kind of figuring this out. But here's the thing. You need to understand what these numbers mean here. 45 is what? Jacob, what's 45? The new area. Right there, right? So this is 45. Let's say it's inches squared, because that's 5 inches squared. All right. That's 45 inches squared. Now, Warren, ready? I want to know, what does this 9 mean? Ben.
It's 1/3. No.
What does the 9 mean? Liam?
It's the scale factor squared.
Okay. Yes, it's the scale factor squared. But what does that mean? Do you know?
Is that like the scale factor of both of them if they were?
Can you?
Well, it's what? Well, you have to square the scale factor because when you are doing area, you square it.
Okay. Maya, can you help me out here? Liam's close.
Oh,
Is it the constant
wait a
of
second.
proportionality?
Kind of. Basically, it's this. Your scale factor squared is how many of those can fit into there.
So like if you turn that into a reptile.
Yes! If I turn this into a reptile, 9 of those would fit into here.
Oh.
That's what the scale factor squared is. It's how many of the original can you put into that. All right. I told you it was going to take a little while. Ben, I love the questions because I feel like we're getting somewhere with understanding. Yeah.
So what I was gonna say, so is it like basically if you divide 45 divided by 9, you still get like 5?
Yeah, because this means how many. This means how many fit in there, and what's the 5 mean?
Times what it is that's been area.
Times how big that is, right? One of those is 5. How many can I fit in? 9. So what's my total area? 45. That's what the scale factor squared means, is that it gives you how many of the little things can you put in the big thing, or how many of the little things can fit in the big. Yeah, I got it confused there. But anyway. All right. Please go ahead, put that away. Please get the sheet out you grabbed at the door.
Oh, this one looks familiar. I read the to and from.
Max is already ahead.
They seem familiar.
Okay, we have like 5 minutes, and there's going to be quite a few notes. So I mean, today we did our independent practice at the start, so now we're getting into this. All right.
What do you mean 5 minutes?
Yeah, we're at 10. That's it. All right, here we go. So we're talking about designing under constraints, and what that means is, if I know the scale factor, I can find missing sides. Remember the I can statement? It was, if I know the scale factor, I can draw similar figures. Well, in order to draw similar figures, I have to know all the sides. So, my scale factor tells me this. My sides must be corresponding to each other in order to find out the scale factor. So, make sure you take your notes here. And this is going to be wicked colorful today. If that's 3, and that is 2, these are corresponding sides. So here are your notes for it. Your scale factor equals your new side, and remember, it should be corresponding, over your, or divided by your original side. So now you need to figure out which one of these is new and which one is the original. Ben?
Wouldn't it be
My focus kids should know this.
the 3?
Wait,
No.
the scale wait, are we looking for the scale factor?
No, I'm looking for which figure is considered the new figure.
The new side would be A because it has the unknown side.
Yes.
Well, not A. Well,
Yeah. This, your new side is the one side that has the unknown. And then this would be the original, because it is known. So your original is always the figure that has the known. And your new is always the figure that has your unknown. So if I go back over here, my new side is going to be 3. And my original side is 2. And they are corresponding sides. Those are corresponding sides. This side corresponds with that. So literally, just by doing that, this is my scale factor. My scale factor is 3 halves. So 3 halves means it's going this way.
3 halves also equals 1.
1.5. You can do that. You can do it that way if you wanted to. You could change that to 1.5. So if it's 3 halves going this way, tell your partner what's it going that way.
If it's going that way, that would be 2/3.
Okay. Make sure to write down these notes.
And then other side would be 12.
So I got 3 halves going that way, 2/3 going that way. So here's my question now. I figured out the scale factor by putting I divided the new side by the original side. I get 3 halves. So now I can finally figure out x. So what do? Is I would go, this side corresponds to that side, so 8 corresponds with x. That means 8 is 3 halves the size of this. So I would go 8 times 3 halves, and I get 24 halves, which equals 12. So that means x equals 12. And this makes sense to me because I'm going from small side to a bigger side, small side to a bigger side. 12 makes sense then. It's always important to think about that. Lily.
So if it's at 1.5 going that way, then what's it going the other way when you switch them, or when you...
That's why I kept it as a fraction.
Yeah.
Because 3 halves going this way, 2/3 going that way. 2/3 is 0.666. See how it's hard if you put it as 1.5, there isn't a reciprocal. If I keep it as 3 halves, there is a reciprocal.
I put it as both.
Okay. You can do that. I can go 1.5 times 8. I know that, right? That's easy. That's 12. Boom, done. All right. Go ahead, work with your partner on this one.
That one's easy.
And I know you can see. I know you can see it, but I want you to do it this way. Go for it. Work with your partners.
The scale factor would be 2. 6 over 5. 6 over 1.
Talk to me. Yeah.
This.
Okay.
Keep talking. I want to get it, Matt. Hold on.
Alright, so this.
Oh shoot! It's not gonna record it. Just talk loud.
Okay. Stop.
Go.
Okay, so the new shape, you know that this is the original, and that this is your new figure because this is the unknown. This is and then you give them that, and then it's
1 times
what's 2 4?
New side.
I actually would give you can turn that into 2.
No.
And no, you can turn that into 3. And then
This is 1 half.
3 can go in.
This is 2 over 1.
That means
2 4. Sorry.
yeah.
Okay. Max talked me through it. He was like, "Hey, this is the new because it has the unknown. So that's the new. This is my original because I know all the lengths. So now I made 1/2 going this way because 2 is my new. There's my corresponding side right there. Here's my original corresponding side, which is 4. I get a scale factor of 1/2 going that way. So then I take the half, I multiply the side I know. 6 times 1/2, 6 over 2, I get 3. X is 3, that's what that side length is. My last question, and this should be quick. How many degrees are in a triangle? If I added up this, and this.
It depends on the kind of triangle.
Ooh, it doesn't. How many degrees?
They're different angles.
They are different angles, but if I added this, and this, I'm going to get the same answer every time. Yeah.
180.
180. So, write that down. There's 180 degrees in every single triangle. Warren, make sure you're getting this down.
Yeah, I am.
Okay. So if I told you this is 92, this is 32, I want to know that. Go ahead, figure that out, and that'll be pretty much the end of today.
So, how many degrees are missing angles? The missing angles what?
Oh, I know this. I know that. I should put degrees
Are we
there.
trying to get the 360?
What is this? No, we're trying to get to
180.
180.
92
Because
plus
every
32.
every triangle is 180.
That's 100 and 9, 10, 11, 12.
Figure it out. All right, okay.
Sorry?
Working on it.
Yeah.
Yeah.
That's 124.
Nice, Orlando.
124. 80 minus 24 would equal 70.
That's 120 right there.
Whoa.
57, 66.
56.
166. 166. Students.
180 minus
So
120.
this angle here, 56 degrees.
Yeah.
All right.
Am I mentally ill or something?
Okay. Listen. We got a little behind explaining everything. Listen. I do want you to do this. So, look at it, because it will be graded. I'm going to grade this. I will give you an opportunity to do it quickly tomorrow. Okay? But this is what we're going to be doing. Homework. 7A, 7B, 7C. Apologize for the lateness. It's on page 62. Have a good night, guys.